Like moths drawn to a flame, our minds crave novelty and delight in discovery. We seek out new, unexplored lands. We thrill to find in these places unique and wonderful animals and plants. From time immemorial, we have dreamt of visiting the stars and the worlds that seem just out of reach, just beyond our fingertips. As soon as we had the know-how, we reached into space, launching artificial moons that we could see and track across the sky. Soon those satellites were looking back at us and at the heavens. And it wasn't long before cosmonauts and astronauts were actually walking in space. In living, to some of us, recent memory, people from our planet set foot on the surface of the moon. It all happened incredibly fast. The way the universe measures time, humankind has only been here for the blink of an eye. And we are already breaking free of our home planet. It was 1961 when the first human was launched into orbit. The following year, Mariner 2 left Earth behind on a voyage that took it to our closest planetary neighbor, Venus. In all, 10 mariners set out on journeys to Mars, Venus, and Mercury. They mapped our nearby planets. We saw them in stunning detail. We even got weather reports. Some were disappointed when the mariners found no monstrous aliens, no tropical forests teeming with extraterrestrial dinosaurs. But our scientific appetites were whetted. Project Mariner was succeeded by an ambitious new program to go even farther. Voyager.
हाँ, पर अच्छा दिख रहा होगा उसको भी.
The scientists and engineers of the Voyager team designed 2 similar space probes to uncover the secrets of our system's outer planets. Voyagers 1 and 2. Their first destinations would be Jupiter and Saturn. But such distant goals brought tough challenges. How exactly could the Voyagers move across the billions of kilometers from Earth to the distant gas giants? Fortune gave them a lucky break. Earth, Jupiter, Saturn, Uranus, and Neptune were all coming into ideal positions. They wouldn't be in that felicitous alignment again for 176 years. The timing was perfect. So on August 20th, 1977, Voyager 2 was launched from Florida's Cape Canaveral. On September 5th, Voyager 1 followed its twin on what would become the longest journey in history. Not long after the launch, from a vantage point almost 12 million kilometers away, Voyager 1 took a picture of planet Earth with the moon in a single frame. For the first time, we saw how small our home and its satellite look from the depths of space. But the perils of a harsh environment and a long journey were building. Now, Voyager 2 wasn't responding to signals from home. The team knew where the craft was, but with no communication, they could not control it. Their precious craft seemed about to become just one more piece of space junk. its mission of exploration would be over. But engineers who could make a spacecraft like Voyager were just the kind of people who could solve a problem 200 million kilometers away. What they found was the Voyager 2's radio was fine, but its ability to tune it was out of whack. NASA's technical team would now have to recalculate the right frequency and retune the transmitter on Earth to match Voyager 2's receiver. They had to do that every time they wanted to send it a message. The connection still dropped out from time to time, but they always got it back. On the 5th of March 1979, a year and a half after leaving Florida, the rendezvous with Jupiter went exactly as planned. Voyager 1 reached and then flew by the largest planet of our solar system. The spacecraft's cameras sent back breathtaking views of a gas giant named after the king of the gods. For nearly 2 centuries, astronomers had wondered and speculated about Jupiter's gigantic red spot. What was it? It seemed just a blemish on the face of such a huge planet. But that spot was 3 times the size of Earth. Was it a gigantic plateau, an alien construction, a signal? The Voyagers helped to solve the riddle. The Great Red Spot is a gigantic storm. By far, it is the largest atmospheric disturbance in the solar system, and it has been raging for centuries. Voyager's observations of Jupiter brought many other surprises. Lightning bolts more than 1,000 kilometers long, and at the poles, auroras akin to the ones on our own planet. With the Voyager's help, scientists could see also that Jupiter was encircled by faint rings, seemingly made of tiny dust particles. When their time came, the Jovian moons posed for their close-ups. Europa, Ganymede, Callisto, and Io. Views of Ganymede confirmed that it is the biggest planetary satellite in the solar system. It's 1.5 times the size of Earth's moon. That makes it even bigger than the planet Mercury. But greater surprises were in store on 2 of Jupiter's other moons, Io and Europa. Scientists had thought that in our solar system, only Earth had active volcanoes. They believed all the other planets and moons were seismically dead. But on Io, the Voyagers could clearly see volcanoes spewing molten lava onto Io's frozen surface. Io's lava flows, some as long as 500 kilometers, were a spectacular sight. The lava blending with black volcanic ash, glittering and glowing. Red, orange, yellow, maroon. The surface itself is a kaleidoscope of changing hues. It's relatively young and dotted with strange depressions, and with mountains towering far higher than any on Earth. Far from being a dead world, Io's 400 active volcanoes make it the most geologically active place in the solar system. The close encounter with another Jovian moon, Europa, was no less intriguing. Scientists knew already that Europa was covered by ice. The Voyagers determined that the kilometers-thick ice coat concealed beneath it an ocean of liquid water. In fact, Europa has much more water than Earth does. 2 or even 3 times as much as all the water on Earth combined.
Oh my gosh. No. कहाँ चले गए? ए बोलो मत
makes life possible? Could it be that extraterrestrial life has evolved in Europa's hidden seas? It's not likely we'll ever find intelligent life in Europa's icy waters. But even the tiniest microbe would spark a revolution in scientific insight.
Jellyfish? Jupiter
was only the first of the planets on the Voyager's itinerary. It was that rare alignment of all the outer planets that sparked the Voyager's travel plans. Their next destination was the mystically beautiful planet that has inspired astronomers for centuries, and it was only a few 100 million kilometers away. It took a year and 8 months to cover that distance. It was November 1980 when Voyager 1 drew close to the beautiful ringed planet, Saturn. Every day of that visit brought new insights. From close up, scientists could see that Saturn's seemingly giant rings were actually thousands of tiny ringlets. Those striking and beautiful reflective rings were made mostly of water. Billions of ice crystals, ranging from tiny specks to fist-sized chunks, encircling the giant planet. Some were the size of a house. On Titan, largest of the Saturn moons, Voyager 1 discovered a beautiful lake district. Other than Earth, it's the only place in the solar system where pools of liquid have been found on the surface. But there's a catch. Titan's lakes are liquid methane, not water. Titan is the only known moon with a dense atmosphere. The atmosphere is so dense that noon on Titan would seem to be twilight to us. Titan would be Voyager 1's last stop on its journey inside the solar system. Visiting that fascinating moon put the craft on a trajectory that would catapult it out of the planetary plane altogether. Sped along by Saturn's immense gravity, Voyager 1 headed up toward the emptiness of interstellar space. Voyager 2 did not follow. It had more places to visit right here in our own solar system. The probe got to Saturn in August 1981, 9 months after its twin. Voyager 2 discovered that Enceladus is relatively young, only a few 100 million years old. That makes it an infant by solar system standards. Its youth has given it a diverse and fascinating landscape. There are areas pocked with craters. In other places, smooth plains flow into areas where the surface is ribbed and buckled. There were also many ledges, ridges, and long cracks. Enceladus is mostly a huge ball of ice-crusted water with a big rock in the middle. Its icy white surface reflects more sunlight than any other celestial body in the solar system. On the other moon, Tethys, Voyager sent back images of a crater 450 kilometers across and 16 kilometers deep. The team back on Earth named it Odysseus, after the legendary Greek hero Odysseus, king of Ithaca. With its time to visit Saturn at an end, Voyager 2 used the force of the planet's immense gravity to speed it up and hurl it towards its next destination, the mysterious icy giant, Uranus.
ठंड तो नहीं लग रही है दुपट्टा नहीं है
For a great while, we knew almost nothing about Uranus, other than it was discovered in 1781 by astronomer William Herschel. The discovery of what Uranus was actually like had to wait more than 2 centuries. On January 24, 1986, Voyager 2 arrived for a visit and an interview. From the first moment of that visit, our eyes were opened to a remarkable and beautiful planet. Uranus is cold. Its atmosphere is 217 degrees Celsius below zero. Its stunning pale blue atmosphere is made up mostly of hydrogen and helium. Voyager 2 made a special study of the Uranian moon, Miranda. It came much closer to Miranda than to any of the others. The close-up portraits it took are stunning in their detail. Relatively small Miranda turns out to have a topography that is unique and diverse. Its rolling plains are dotted with craters and scarred by a web of huge fractures, canyons, and escarpments. Miranda, it seems, had a stunning and violent past. It had been shattered by a violent collision. In the aftermath, gravity drew the broken pieces back together, and Miranda was reborn. Voyager 2 spent only a couple of days near Uranus and its system before its momentum and Uranian gravity flung it toward its last rendezvous with Neptune, the other ice giant. Voyager 2 neared Neptune in August 1989, 12 years after its launch from Cape Canaveral. During that time, the probes had deeply enriched our knowledge of the solar system. Now it was time to make more than a few final discoveries. Neptune's dynamic atmosphere and its startling weather changes was the first discovery to excite the attention of the Voyager team. In the extreme cold of deep space, they had not expected the energy to fuel Neptune's meteorological fury. In Neptune's southern hemisphere, Voyager 2 discovered what is now known as the Great Dark Spot, a permanent anticyclonic storm. Voyager found that Neptune's winds were the strongest in the solar system, their speed reaching up to 2,100 kilometers an hour. Voyager 2 also found a weak and fragmented system of rings encircling the planet. What the rings are made of and why they have a reddish hue is a mystery Voyager could not stop to answer. But there were more insights that were gained when Voyager 2 flew past Triton. Triton is the only large moon in the solar system with what's called a retrograde orbit. It moves around Neptune in the direction opposite to the planet's rotation. Scientists think that Triton's unusual orbital direction proves that it once was a dwarf planet of its own. Millions of years ago, it strayed close to Neptune and was captured by its immense gravity. That retrograde orbit means that Triton is always losing energy. Sooner or later, the moon will be destroyed. Triton's fragments will likely create a system of rings around Neptune, more substantial and visible than even those of Saturn. Voyager also found that Triton is one of the coldest objects in the solar system. The surface temperature dips down to minus 235 degrees Celsius. So, the scientists were amazed to find near Triton's south pole what they call cryovolcanic activity. A range of geysers that spew nitrogen and dust through cracks in the surface ice. The plumes are so powerful they can reach 8 kilometers above the surface. Neptune and its moons were the last stop on Voyager 2's journey through the solar system. From now on, like its twin, the spacecraft was headed outside our home system of sun and planets. Voyager 1 became the first man-made object to reach the boundary of the solar system and to pass beyond it. That happened in August of 2012. Voyager 2 is not far behind. Now both space probes are moving away from our solar system, each in its own direction. Their missions completed, the Voyager's onboard devices are gradually shutting down. At the very end, somewhere between 2025 and 2030, a half-century after their journey began, NASA will lose the connection to the Voyagers forever. But what could come next? Even after the probes can no longer send data back to Earth, the two valiant Voyagers will continue, moving farther and farther away from our sun. Millions or billions of years will go by. Humanity may be long gone. Even our own sun will eventually become a red giant. Even then, somewhere far beyond the farthest boundaries of our solar system, two human-made space probes will be carrying with them small tokens of who we are and who we were. Someday, the Voyagers may be the only evidence we were ever here at all. Voyager 1 and Voyager 2 each has on board a kind of time capsule. In it, there's a gold-plated copper disc and the stylus needed to play the sounds encoded in its grooves. Instructions on the cover explain how to make a record player. Whoever does that will hear greetings in 55 languages and be able to listen to the music of Mozart, Chuck Berry, Bach, Louis Armstrong, a Georgian choir, the ritual songs of New Guinea, the sounds of nature, and the songs of Earth's birds. The disc carries photos of Earth taken from space, of earthly landscapes, and the people who live in them. Scientists calculate it'll take about 18,000 years for Voyager 2 to get 1 light-year from home. Then it will come as close as it ever will to a nearby star, Proxima Centauri. That star we recently discovered has a planet that might, just might, be hospitable to life. Maybe by that time, humankind will have found a faster route to the stars than the one Voyager's travel agents knew about. And possibly, sooner or later, those Voyagers will complete their journey by bringing news of who we were to intelligent creatures whose desire to reach the stars mirrors our own.